Aloha, Richard Halverson here. This is ICS321. And today we're going to start chapter 4. So let me share my screen. We are should have done this earlier. Summer 21. We are in chapter 4 here, and today is the 23rd. So it looks like we skipped past this, but anyway, so we're going to start this today, and this is a pretty easy chapter. It's SQL. You've seen a lot of SQL already, and all of the weird things we've sort of covered a lot. We've covered a lot of that, like how to set up the foreign key constraints and so on. We already know all about those, so it should be pretty quick. I'm still trying to figure out the problem with the comparing your views to correct your views. And what I do is, like, for example, this is mine, Richard H, and this is my database that I've created, and there's a view there. Yeah, there's the view original there. And then what my program does, what my grader program does is that's over here, and it actually exports it. It goes into your account and exports it into here. And so I can see, I'm tracing it through, and I can see my stuff there, and I can see the view is there, but it's just when the view is tested down, and I don't know how much of this you see, but the view is tested here. So here is where I have copied over your database into this test database. The original database is up here. Here's the original, and that looks fine. And then I go select the test database, and I execute it, and I don't get anything back. Now, so I'm suspicious if you actually export this database, and you can do all this if you want to. You can just check all this out. But I'm just going to export the view, and I'm going to just view it, and I click go. And so this is the view. Now it creates this thing. You aren't really creating a table, but I don't think that does anything. But this is the actual thing that's exported. Now I'm wondering if the fact that this is part of the definition of the view, it's actually, that part there is not necessary. The statement is create view original as, and then a big long select statement. So I don't know. I'm in the process of debugging this. But the worst case is there's only 20 of you, and I manually grade it. But the other thing is that if you've gotten all the rest of them right, you probably got that one right too. So I might even take a shortcut. But anyway, and I'll share with you the solution after I figure it out. All right, so let's just get started with chapter 4. So it's introduction to SQL, and perhaps this chapter should be covered earlier before I give you some of these assignments. But the assignments are kind of due. Was 22nd? That was yesterday. But I'm obviously not gonna. I'm not gonna grade that for a little while yet, or score. You're getting your grades here, but copying them over into Laulima, I haven't talked to the grader about that yet, but I think maybe we aren't going to start that till July, or maybe the middle of July or something. So, and of course it doesn't, it's not the drop dead date is August 13th is the last day of class, and I think I probably have to have my grades in on the 17th. And since everything's auto graded, you know, so I'll be doing my grades around this time. So make sure you get everything done by this time, because then, you know, when I copy out the grades, they're all there. So that's really what your deadline is for getting all the points that you can get. And I don't discount for anything before that and end time there. So SQL, it's a structured query language, and we pronounce it SQL or SQL. And I think there actually was a brand of structured query language a long time ago called SQL, but I haven't heard about that for about 20 years. But it's the language used by database designers and users to interact with relational database systems. And you know, we've studied relational database systems, chapters 1 through 3, and so we see there's a whole there's mathematics behind it with section 2.9, you know, the Greek letters and so on, and it's sort of a whole mathematical language in and of itself. And so there's this language that they developed back in I don't know, the 80s, I guess, to a language that they just kind of standardized on creating and manipulating these relational tables that formed the database. And they've never really deviated. I mean, it's not like somebody else has come out with a different syntax language, or, you know, how there's lots and lots of programming languages, and programming languages all do pretty much the same thing. There's loops, for loops, while loops, if else structures. But you know, Python, if you've ever written Python, it's very different than Java. I mean, it's, you know, the semicolon is important, you know. But there's SQL, and that's all there is. And the other thing about SQL is, I think we discussed some time ago, and that is that SQL it's not a procedural language. It's not a language. You know, when we are writing code, or when we write an SQL statement to select and display certain columns out of a table that meet this criteria, when we write the code to do that in SQL, it's just one statement. If we were to write code to do that in Java, we would write some code, and there'd be a loop or tests and stuff and so on. So it's up to the database management system underneath to take your SQL statement and generate the sequential code to get your answer. And, you know, of course, there's optimization and everything else. But anyway, they've never felt the need to come up with anything other than what they came up with back in the 80s. And so that's what we're going to talk about today. And that's what you've seen already. SQL covers everything. It covers the database designer who's designing the tables and everything, and creating the database, starting from creating the database itself. That person is using SQL commands, and then the user who's writing the SQL commands to do selects, to select tables and update tables and join tables and all those other things. That person is also using SQL statements. SQL commands can create both databases and tables, and the database designer and the database user both use SQL, but not all database systems use identical SQL statements. And by that, you know, there's got to be some reason why Oracle is more expensive than MySQL, and it has to do with fancy functions like, you know, select cities that sound like Indianapolis, or yes, you know, some really you know, far out kinds of things that clearly the database engine is doing some work, and you know, it took some pretty crafty programmers to be able to provide these kinds of functions in just a form like you included in the where expression of your statement and so on. But here we're just learning the SQL, the 95% of the SQL that's common in all SQL languages, whether it's Oracle or Postgres or MySQL or the Microsoft SQLs. And I'll probably talk a little bit about some of the differences that we may encounter, that you may actually encounter. But I'm actually not very familiar with Oracle, the added features. I looked at it a long time ago, but anyway, it's expensive. So the syntax is as you know, there's the select clause, and this is these are the columns or the fields, the projection, the projection part from, and this is this here is a relation, and it's usually just a table, but it can be tables joined, or it can be another select statement, because the select statement produces something that looks like a table. And then this is the restriction part, the where clause, where you limit the number of records that you want to see by, just, that fit certain criteria. And so this whole thing makes up the statement. We have literals. We put things in quotes. I don't know about double quotes. I don't think double quotes works all the time. So be careful about this. And then this is how you would say binary values. If you put an X in front of it like that. Okay, so I've got my P table here, and I'm going to do select P from P where P color equals single quote red. Go. Okay, now I'm going to make it double quote red. Can you see that? Double quote red. And I don't think this is going to work, but if it does work, I will not be surprised, because adding new stuff all the time. Yes, it works. Very good. All right. So I learned something new today. Works with that with MySQL. But there, of course, there are keywords, words with special meanings, and objects. These are the field names, for example. And then you can have comments, dash, dash, and then the rest of the thing, and then or you can put multi-like. Now, this might be used sometime, but this is only used like when we are going to be writing sequences of SQL statements. And of course, sequences of SQL statements are stored procedures and triggers, and we'll get to those. So insert statements identify how many clauses are in the insert statement. I don't know, I guess 2? Good question. Yeah. So anyway, I can do these sublime. Okay, so here they talk about this when they talk about SQL. When you're studying SQL, there is the data description language, which you use to define the structure of a database, and that would be like the create statements and so on. There is the data query language, and those are select statements and being able to join and all that kind of stuff. Data manipulation language, those are like update statements, insert statements, statements that change the database. The data control language has to do with user access, and the data transaction language is manages the database transactions. And I'm not sure about language other than you can identify the start of a transaction by the word transaction and then the end of a transaction. And then everything in between is considered a transaction, but it's just a bunch of SQL statements usually. So you would see this in a stored procedure or a trigger, which we'll get to. The data control language, that's over here in your cPanel. If you've got your cPanel, it looks like this. Just be inside here, and you have your in here is where you would control the users. So there's users down here, different users, and users have permissions to access certain okay, let's we don't need to do this because when we're accessing the database using phpMyAdmin, we are actually the owner of it, so we don't need to, it's sort of an implied user, but we can add a new user, like Joe, and give Joe a password. I don't know what, here, I'll just do password generator. That's a nice password. So I'm going to copy that, and I should store that away someplace. And I say use password or whatever, and I do create user. Well, they don't, do they? That. Okay, and then so once, oh well, anyway. Oh, that's one thing about this thing. When you create users and you do the password, this thing reverts back to a default. So I just created a user named Richard H, which is stupid, but and I'll probably go to delete that. Oh, I created a user named user before. But anyway, so then you give the user access to a database, and you click add, and these are all the kinds of privileges. This is the breakdown of all the kinds of privileges that you can give a user to access a database. And this is where you do that. So this would be the data control language. Well, this is a nice form. This is a nice form which probably produces some kind of data control language statement that gets applied to the database, and we just see it as make changes, and it comes and says, success, you've done it. And then when you go back, you see that this user has access to this database. All right, so this little participation activity goes through and shows what each data description language creates the database here. The data query language selects the table, displays up data. The data manipulation language would do an update, changing Lopez to LATT, and then the data transaction language would actually commit the database. Yeah, I mean, it's kind of this is not a good example of it, but anyway, so it's got a lot of capabilities in there, where if you create a transaction that's a series of SQL statements, and you're going along executing the statements, and something goes wrong with one of them, like you try to like let's say some foreign key constraint was violated. You try to do something and some foreign key constraint is violated, then that means that transaction failed. And if the whole thing is, or that particular execution failed, and if the whole thing is within a defined transaction, transaction means they all have to finish successfully. And if any one of them is not successful, then none of them are. Then you revert back to the way it was before you even started the transaction. And of course, that all has to be managed. So that's what that is. And then the data control language is, controlling the users and stuff. Let's I'm going to go in and delete this. I can just delete this dumb user here. Delete permanently. Permanently deleted. And what happens here? Okay, so the user goes away. All right, so you can figure this one out. So creating and dropping databases. Now, I've never actually written SQL to create a database. I always, if I'm creating a database on my server, and I mean, it's like I only create databases on my on a server. I guess if I'm creating databases on my personal computer and I'm running Microsoft SQL or something, and I'm using an integrated development environment that's got a database built in, then I guess I would use these create database statements. But in anything I've ever done, I've always created a database from something like this, where you create the database here, and then once databases are created, you are able to go into, go over to PHP-MyAdmin, and some PHP-MyAdmin implementations, I think you can create databases, but in this one you can't. I don't think you can, but I didn't think you could use double quotes either. So maybe you can, but maybe once I tried it and I did something wrong and it didn't work, and from that I concluded that you can't create databases. But I know there are levels of restrictions for creating databases, users' ability to create databases, and so I'm not sure about that. But anyway, I just create them in this tool here, this databases tool. There's a wizard here too. I've never even tried that. All right, so this create database and drop database, and it's just like create table and drop table, which we'll look at in a moment. This creates a database called auto. It's show statements work. Show databases. Yeah, I'm sure show data. Let's try show databases. I'm gonna go here, and I'm gonna click on SQL, and I'm gonna say show databases. Go. Yeah, okay, so that works. That's show databases. And we have show tables. So you have to have a database selected first. Show columns, show create table actually shows you, it actually gives you a create statement to create the table that you're at. So it's kind of like used for, it can be, you can think of it like have it being used if you want to export just the table structure. And let's say you have a stored procedure and you want to duplicate a table. That's a way that you can do it. Show tables you'd have to go into select the database. So I'm going to select the first database here. And so now I've got a database selected, and I can go show tables. And it shows the tables. I think show columns must be, you have to say a table. Yeah. So anyway, those are just SQL statements. Oh, here's how you would tell it what database you want to use first, and then from then on until you have a different use statement, that's the one you're using, and then these kind of statements will work because the database has to be selected for that. All right. Which statement shows all databases in a database system? Well, I think it'd be this one. It's pretty easy. All right. Okay, so now, adding and dropping tables, we do this also, but again, I do it in PHP My Admin. And just go. You can just take a table, find a table, and drop it. I'm not going to do that, but this one, song, you can just go to operations, and these are a bunch of those kinds of data, whatever they were called. What were they called? What are these different language terms? Let me just go back to them again. Okay, so manipulation, control, transaction, access, use of data in the free structure. Okay, so anyway, I just wanted to. So these do things like rename the table, copy a table over to another table. So they're kind of some maintenance kind of things. I guess it'd be in one of those categories. But anyway, let's see, where was it? 3. So there's the so for a table, you can just look. This is delete all the rows of the table, and this one is drop the table. This one is delete the table, and this one is delete all the rows in the table, but the table still stays there. The structure is still there. And so here it talks about the different data types, and there's a bunch of different kinds of integers, and of course the difference is the size, how many bytes are used, and if you can get by with just 4 bytes with just this, that's probably the best, because for all these other smaller ones, there has to be some more shifting and manipulation that goes on, and this is sort of cascading or doing a double word kind of thing. And so that's why, to me, it's not so necessary to worry about these smaller ones. And then these are decimals. And so when you look at any kind of like here's a table. Let's look at, well, okay, so here's a table structure, and these, you remember, were an employee ID and a project ID and the number of hours that the employee worked on it, or some such thing. And so when you look at the different types, there's just a whole bunch of them. There's all these different types, and they're all right here. So when it comes time to create a table, you just can select it, and what you can do is you can create the table using something like this, where you create a new table, and then after you have a table, whatever, then you do the show create table, and do I got to say the name of the table? That I do. I think I only have to do ASMT to Q2, is that? Oh no, so that's the database. Oops, employee. There. And so then this, voila, you have the create here. Let me see if I can options, full texts. So you see it, this. So what happens? You have something like this. What happens is what's returned is a table. It's a relation. Got 2 columns. There's a column. First column's name is table. The first column name is table. And the second column name is create space table. And this is obviously a text field because it's going to be big. And so here we have the create table statement. And so for any table you have, you can just, if you want the create table statement to produce that table, you just do this create table thing. So here's foreign key constraints, because this one has a foreign key to zip refers to the zip city, the zip field of the zip city table, and so on. So anyway, these are all the different kinds of types, and this has to do with when you might use one or the other. Yeah, understanding the decimal parameters. So here's the create table and drop table statements. I just showed you the create table. You can actually create a create table statement from a table if you already have the table. Otherwise, you have to write it. But see, this is a create table statement. And so just like we saw before, you know, we have this is, you know, the definition of a field. It's got a type, you know, and a name and so on. All right. So these things are pretty cool because you actually like, okay, so we have to write a create table statement here. And so, well, I don't know, what is it? Create. Can I copy this? Create table. Here, I'm going to copy this. I know I'm lazy. Create table product. Column name ID is an integer, I bet. And column 2 is name. Column 3 is product type. And product, see, name is what am I supposed to do? Oh, varchar. Oh, unsigned integer. What is the unsigned integer? It is.
Yeah, I think you just type in the word unsigned.
Unsigned in front of it.
Or
I guess. Okay. Unsigned. Do I have to put a number here?
Or they put the does it matter whether unsigned is before or after? I think in their example they put it afterwards, actually.
Okay. Oh yeah, you're right. I'm pretty sure you're right. And then this would be a varchar. Is it 40?
Yeah. Then for product type char.
Yeah, fix that. Okay. And origin date.
I guess that's just date. Yeah.
And the last one is weight. Is unsigned
so decimal, and then
don't I have to put some parameters though?
I think I just put like 5,2 because
Let's wait. Okay.
Or
is that enough? Okay, sure. All right. So you think that's right? Close? Let's see.
I think so.
Does it tell me if it's right or not? No. Let's see what the secret is. Yep.
Oh, okay.
Very good. Cool. We're so smart. Okay, so okay, then there's this alter statement. Like, let's say you want to alter table name. You want to add a column. Okay, this add, change, drop. Well, you can just go see for yourself. I'm going to go down to my test here, and I'm going to. I got a table here, and I'm going to add. Wait. Oh, go to structure. Oh, I'm at structure. This is a table. So let me go into the structure of the table, and I want to add a column after title, and I'm going to call it something. I don't know. And then I go save, and it actually shows you what the alter table statement is. So this PHP my admin can be a handy thing for learning all of these SQL statements too. You know, you might be writing a stored procedure, and you want to you need to change a table. Well, no, you might even be writing PHP code, and you want to change the name of a table or something, or add a column. And so you know, and you're asking yourself what the statement is, and you can go to the alter table documentation and try to figure it out, or you can just go to phpMyAdmin and do what you want to do in phpMyAdmin, and then see how phpMyAdmin does it, and then that's what you use. So anyway, alter, that's alter, and then you can alter a bunch of things. Add columns. You can change column names. You can change, drop columns and so on. Here's a challenge activity. We're in section 4.3. Okay, creating and dropping. To complete the following statement to create a table named country. 3-letter code. Name stores the. Okay. So let's just start. Let's do one of them. Oh, complete the statement. Table named country. I put some code. Create table.
Create table.
Yeah.
Country.
Yeah. ISO code would be char 3.
Yep.
And name would be
varchar
6. Yeah.
Oh,
I forgot to do something.
Would that be drop?
Huh?
To delete the above table with that.
I went and screwed up. I selected.
Oh, sorry.
So now I got to do it again, right?
Oh, okay.
Oh, no, it's letting me. Okay,
Oh,
so
great.
enter. Drop. Is that it?
I think so.
Oh, table. Drop table.
Oh, sorry. I was doing it off the top of my head. Sorry.
Yeah. Is it the same? Is it exactly the same? Oh no, a date. Okay.
Almost the same, but create table country char 3, and that would just be date. Then drop table country. Okay, got it now. Thanks.
Better be right. Okay. All right. Good. Primary key and foreign key constraints, and for primary keys, we add this at the end here. It can be two, like SP, the SP table here. If you show the create table, is that all I gotta do? Is, well, I can just do export and custom text, and I don't need to see I just need to see the structure. So here we see, oh, this does it differently. That's right. This actually creates the table just plain with nothing, and then afterwards it does alter table instructions. And there's some advantage to. Oh, and here's the foreign key constraints down here, because this table, the PNO field references P&O field of the P table. This is the SP table. You know, there's the S. This is the, so the primary key is both these together, and this is the primary key into the suppliers table, and this is the primary key into the parts table. But you can still do it the other way. Is this worth going back? Oh, that's good. And dump view as text. I only want to see the structure, and I want to add trigger statement. I think I want this. I want to take away that. Oh, here, I want to take away this. Enclose export in a transaction. Now let's see what it's like. Oh, still didn't work. I'm trying to make it so it actually combines it into, so it's just one table, but this, I see, this just took away the, so I'm not sure. You used to, MySQL, you used to be able to do that. How about if I try it this way? SQL. Show create table. Options, full texts. Go. Okay, here it's all in one. So if we copy this out, copy, and I don't know, paste it back up here or something so we can see it. So here this combines it all into one statement. That defines the primary key, and this is another key. Oh, all right, that's interesting. I wonder why that might have been a mistake. Maybe that shouldn't be. Maybe this is maybe that's not necessary. It's got these two foreign key constraints. I don't think this one is necessary. Yeah, that's a unique, that says that was unique, and so I don't need that one. This is just a, oh no, I don't mean to, oh, well, forget it. I don't need to fix this. So anyway, so it looks like you can use PHP-MyAdmin to produce these things also. Oh, auto increment. You know, when you want to just assign or have a primary key and you want it to be meaningless, you want it to be meaning free with no meaning, that's a nice parameter to have. Let's see, employee table might be auto increment. Is EID auto increment? No, it's not, but it could be. And so that's just in PHP-MyAdmin, that's just a auto increment. Of course, that's what A_I stands for, auto increment. So if you wanted to add that auto increment attribute, you just click on that thing and it would probably work. I'm not gonna bother to change it, but well, you can see it. I don't think this matters. Oh, never mind. I think the problem is there's already data in there, and so it may have wanted to set that. Well, anyway. All right, so that's so that's very valuable because you know, and then the database management system takes care of automatically incrementing it. And so whenever you add a new employee, you don't say anything about ID, and the database management system takes care of making sure that that's a unique ID. And sometimes when you're writing PHP code, you want to insert something into a database table and it's auto increment. And then right away, you want to get back the ID that was assigned because you don't know what it is. You want to get that back and you want to use that to, you know, insert something into another database table that has this one as a foreign key. There's, you know, statements for that to get back the auto increment value of the last record I inserted. Yeah, so they've thought of all that. And here's the foreign key constraint thing that we saw. Looks like that. So what happens when I run this? This is amazing. This is all like, you create a table, create another table, show some columns, you know, so on, and just like shows it all here. You can change this up again, create album 2, and it's fine. Album 2. A foreign key constraint must reference a primary key. I think that, is that true?
Yes.
Adding a foreign key constraint to a table only affects inserting new rows into the table. Adding a foreign key, I don't think that's false, right?
Let's see.
Yeah.
Yes.
Inserting
Yes.
and updating rows are affected by inserting it. Oh. All right. Well, anyway, I was thinking of something else when I said false, but so yeah, so we know about these, about foreign key constraints. You know, when you're adding, there's a foreign. This is a foreign. This, you know, in the SP table here, you know, we have parts, we have suppliers, and then we have this other table which has got this is a supplier, this is a part, and this is a quantity, and these two things are the primary key, and then these are also foreign keys. So when we go to structure and we look at relation view, we see that, excuse me, these are foreign keys, and here are the constraints: on delete is restrict, on update is strict. I'm not sure these are correct. I'm not sure these are correctly set. Well, yeah, I think they are. And that's this on delete, on update. Where are we? It's 220. Yeah, dropping a table is tricky if you have these foreign key constraints. Now, just in case, you know, with these databases, this is something with MySQL. Okay, so these are foreign key constraints, and we shouldn't. Okay, we shouldn't be able to delete. I'm going to do this in case it's we shouldn't be able to delete P4 because it's referenced here. So if we do try to delete P4, yeah, we can't delete it because the foreign key constraint. And what was I? Oh, I think all I was going to show you was I can't remember what I was going to show you, but if you see the structure and you see the relation view, oops, I'm on a different table. Actually, I think that's all I was going to show you. I was going to show you how that works. Foreign key constraint references the table's primary key and cannot be deleted with the drop table. Okay, no, I was not going to drop the table, but But I think maybe what I was going to talk about is there has to be an order in which you delete. What I was going to show you was when you're creating a table, okay, let's just take this table here and go over to operations. And there's different database engines. And certain database engines will enforce foreign key constraints, and other database engines will not enforce foreign key constraints. So if you want to enforce foreign key constraints, and in this class you probably do always, then use INNODB. Use that database engine when you're creating your tables. Supports transactions, row level locking, and foreign keys. Whereas the default is this my ISAM, and my ISAM is a storage engine you may want to switch to after you're all up and running, everything works fine, all your code works. No one's going to try to delete no one's going to try to delete a record that's being referenced by some other table in a foreign key, and then you can switch to my ISAM, and it's a lot faster. It's a lot faster. But don't accidentally leave it my ISAM when you're doing these assignments, because it's not going to enforce the no delete thing, and it's not working. You put the foreign key constraints in there. You can put them in there, but then you go and delete the thing. And now that's what I remember from before. But again, I didn't think the double quotes would work. So. I'm still not sure the double quotes work all the time. Let me, what time is 2:24? Okay, so okay, foreign key constraints, column constraints. Yeah, these are column constraints. Not null, which means it has to have a value. So that means if you try to insert a record and you're not specifying name, then and it's not specified, there has to be a default specified. And if there's no default specified and it's not null, then it'll reject the insert, which is what it should do. And so this is defining a default. So you may say this is not null, you may say the birth date is not null, but if you don't know the birth date, it's going to insert this birth date. This is a constraint, which is just means that it sort of treats it kind of like a primary key, where you can only, if there's a username in there, and you try to put another record in there with the same username as some other record, it will reject the insert because of this unique thing. But you can have a null. You could have a null username, and that would be okay. Right? That would be able to be inserted. Check is I've never used this before. I don't know if it's available in MySQL. We could try it. Let's see. I'll try to make it. I'll put it in this. I'll put it in this database, and I'm just going to put that there, and I'm going to see if this. Oh. A reserved word cannot be used as a column without backquotes near check. Huh. It doesn't, it's an unrecognized state. Okay, so I think check might not work. But that check might not work. Does this check work? Okay, maybe this type of check doesn't work, where it's just in all by itself, birth date's got to be less than higher date, which makes a lot of sense. Let's take this out and see if the errors go away. Yeah, the errors do go away. So this might be okay. Let's see. Okay. So we have an employee database here now that says that the hire date has got to be after January 1st, 2000, before that time. So I'm sure that check works. But we're almost out of time. But I wanted to check something. I want to go down to these SQL labs, and I want to do select movie. Okay, select movie ratings with a left join, and no, that's not what I want. With constraints, insert rows into a horse table. All right, I'll tell you what I'm getting at here, and that is that I remember last semester students were doing they would have problems with solutions that required okay, so I'm going to try this one. This is the solution, and paste this here, and I'm going to change this one to double quotes. See if this works. It worked. All right. Well, anyway, I'll have to track that down. So I've covered up to section 4.5, I guess. And so next time next time I'm going to have solved the grading problem. Okay, I will have solved this problem by tomorrow. So the next class is the next class recording will be done tomorrow at what, 10:30, I guess. So yep. I will see you. So we'll see you then. Okay.
Okay. Thank you so much.
Yeah.
Thanks. Bye.